Alright, ladies and gentlemen, welcome to the XR Gesture Recognition Studio Project Pitch. My name is Austin Matthew and my teammate is Esteban. Our goal is to sit down and create two parts, basically gesture recognition models, but also an entire system, the Gesture Recognition Studio, for recording gestures in VR and training the models all together in one, where you'll just sit inside of Unity with your headset on, mess with everything, record gestures, get with your team, have them record examples. To do this, we're going to need a couple models at base. We're going to use DeepAE. That is one of our aims. That's a model I made that extends DeepGRU. DeepGRU is a gesture recognition model known to work in VR already. DeepAE is just an improvement on it, and there's going to be a series of improvements on DeepAE as well. There's going to be a genetic algorithm. I'll leave that to my teammate to explain. But finally, there is Gesture Studio, okay, and this is probably going to take too long to explain. But long story short, there'll be a panel where you can select yourself, the user, or hit the green button and create a new profile. While you're working, you're going to want to flip through these different gestures, recording, making records for any given one, and also you'll probably have some kind of way to specify what equipment you have. A sample mode, which you would use to you flip this, and then any sample you provide will just be logged. If you flip this down, we'll go ahead and test on that sample so you can get a feel for your gesturing ability. So there's going to be a big red button to retrain the model you have in the back end, and that'll flash up some accuracy. So some other stats we want to show the user. The total count of samples for this gesture that they have selected here. How many this user provided, and we're going to need that to balance the data set. Here is a mock-up controller, and note that this red button here, this is how you segment your gesture. So when you press this, we're going to start, that's a segment, the gesture begins, you do your motions. This light here in the background is going to come on, this recording light, and let you know that you're actively recording. When you let go, your gesture is done, and so either it'll become a sample or we're inference on it live. Now, another important note is that we're going to keep all of these samples in a cloud server so that any member of your team can get on and use them and retrain or what have you. We'll keep the models in there. This is DeepAE, and so here in gray is old DeepGRU. It's a gesture recognition, a deep learning gesture recognition model. I've extended it to Deep Autoencoder, and what that enables us to do is not only recognize your gesture, but recognize if you're performing your gesture correctly. Here's some stats to say that that works.
Hello, my name is Esteban Segarra. Today I shall be presenting my contribution to the project pitch, which is the generic algorithm gesture recognizer. This is building off Dr. Laviola's DeepGRU, Deep Gesture Recognition Utility, and it's a little bit of a variation from Austin's implementation of that paper. So, of importance out of those papers, essentially it is the encoder part, which essentially takes in an input gesture or picture, compresses it down to have its most important components, so which parts of a gesture might be the most recognizable. And then it essentially is trying to convert the time series problem into a semi-static problem, which can be then fed to the generic algorithm. The generic algorithm produces two things. The first is an accuracy score and also the weights associated with a gesture. So in this case, if you run the generic algorithm on the data sufficiently long enough, you're going to have weights associated with the features that are inputted from the compressed features. So we take snapshot of the weights that represent one gesture, and then we get another snapshot when we are actually validating for a gesture. The idea is that once we get to this classifier, we do a comparison between expected and predicted. So expected will be the templated weights, and the predicted will be the validation. And the GA's own score can also be taken into account, but we are trying to primarily compare the weights that we are going to be getting.